Hello everyone, I'm Seungyeob Choi and I'm in charge of building streaming platform at Verizon. In this presentation, I'm going to talk about how to use NGINX for streaming. I think that some of you might not be familiar with streaming, so the first thing that I'm going to talk about is I'm going to give you a brief introduction about streaming. Then I'm going to show you how to turn an NGINX server into a streaming server. And using NGINX for streaming can be done by using NGINX RTMP module and NGINX Plus, but there is some components missing from there. In our use case, we wanted MPEG-VOD that is missing in NGINX RTMP module and NGINX Plus, so we have built the MPEG-VOD module on our own. And I'm going to share our experience with you. And I'm going to move towards a little more advanced topics like HLS version 7 revision 20 and encrypting HLS and high bitrate streaming such as 4K or 8K stream. And last thing is I'm going to talk a little bit about low latency live. What is streaming? There have been a lot of different streaming technologies during the last 20 years. Prior to 2010, most streaming platforms have been built using proprietary protocols like RTMP or RTSP. Since around 2010, the whole streaming industry has shifted towards HTTP-based protocols like Microsoft Smooth Streaming, Apple's HLS, Adobe's HDS, and now MPEG- is getting more and more popularity. They are just different implementations of the same idea. The basic idea is you divide the original MP4 file into smaller segments, and players make requests for each individual segment, and once the first segment is downloaded, and then the player starts playing it, and while it is playing the first segment, it starts downloading the second one, and at the end of the playback of the first segment, the second one is ready at the player side, and then it starts the second segment. By this way, it can seamlessly playing from the first segment to the last segment. And in order to do that, we also need to prepare a playlist. Playlist has to include the list of all segments so that the player knows what segments are going to be offered from the server. Those playlists and segments can be either pre-processed in advance and stored, or they can be prepared on the fly upon request. The simplest way is to pre-process everything. If you want to pre-process, it's simple. You only need to run FFmpeg with these parameters over MP4 file. Then it will generate a playlist with that M3U8 extension and segments with that TS extension. Then you store the M3U8 and TS files in your web server. Then the player makes a request for the M3U8, and then the rest of the things are going to be taken care of by the player and the server. This is how you generate HLS files. MPEG- files can also be generated in a similar manner. Instead of using FFmpeg to repackage the segments, we need to use MP4 box. That is repackaging MP4 file into a fragmented MP4 file, and that is included in the GPEG package. And the remaining thing is pretty much the same. Only the format is different. Then we don't want to pre-process everything. If we pre-process everything, then we have to store both the original MP4 contents, M3U8 and TS for HLS, MPD and fragmented MP4 for MPEG-. That is going to use much more storage space than necessary. So usually in streaming technology, what most servers are doing is we generate the playlist or segment only when it is requested. So the server has only the original MP4 file, and then the HLS and dash files are dynamically generated only when it is requested. If it is a live case, then the encoder is pushing the live stream through RTMP protocol to a streaming server, and then the streaming server repackages the ingested RTMP stream into either HLS or MPEG-dash files. NGINX server can turn into a web server if we add NGINX RTMP module. NGINX RTMP module is an open source module. You can download it from that URL. And you also need to download the source code of NGINX, and you need to compile it with this NGINX RTMP module included. Then NGINX server will start behaving as a web server, streaming server. Once you compile with this RTMP module included, then all you need to do in order to offer a live stream using NGINX is to add this config block in NGINX config. It needs a separate RTMP block outside the main HTTP block, and you need to define server, application, and inside the application you need to put live on, HLS on, and HLS path. Then when you push your live event through RTMP protocol to NGINX server, then NGINX RTMP module is going to repackage the ingested RTMP stream into HLS, M3U8, and TS files in this directory. So when the Apple devices make a request for M3U8 file, then those files are offered from that directory. Dash is also supported. You need to put dash on, dash path, dash fragment, then it generates the dash MPD file and fragmented MP4 segment files. A good thing is you can turn on both HLS and dash at the same time on the same application. Then you publish a stream to NGINX. Then NGINX RTMP module is going to generate both HLS files and dash files from the ingested live feed. RTMP module only does live. It doesn't do VOD. How do we do VOD then? NGINX Plus has VOD feature. If you use NGINX Plus, then you can define an application and put HLS and HLS fragment. Then HLS VOD files are dynamically generated by NGINX Plus from the disk. The MP4 file stored in the disk. And unlike RTMP module, NGINX Plus needs the application included in the main HTTP block instead of the separate RTMP block. NGINX Plus also does HDS. It dynamically generates the F4M HDS playlist file and also HDS segment files on the fly when it is requested in the similar way. But something that you need to keep in mind is for HDS, NGINX Plus doesn't generate the files directly out of MP4 file. You need to run FOF packager in advance to generate FOF file. Then once you have an FOF file, then the rest of the things are taken care of by NGINX Plus. However, in our use case, something was missing from NGINX RTMP module and NGINX Plus. We wanted MPEG-dash VOD that is not offered by NGINX RTMP module or NGINX Plus. And also, we wanted to support newer version of HLS, HLS 7. Both NGINX RTMP module and NGINX Plus generate HLS files based on HLS version 3. But these days, more and more customers want to support more newer version of HLS. So for this reason, we were not able to use NGINX Plus for our use case. So we decided to build the streaming components by ourselves. All we need to do in order to offer VOD streaming is to create a MP4 parser to read the MP4 file to extract some kind of information to generate the HLS or MPEG- file. And then we also need a repackager. Repackager is just not having to touch the actual video and audio, but it just repackages the outside container from the original MP4 format to either MPEG-2 TS for HLS or fragmented MP4 for MPEG-. Once you build the parser and repackager, you can combine them together and connect it with the incoming request to NGINX by simply setting up a FCGI script or something else like NGINX module or whatever. Then whenever we receive a request, the FCGI script is translating that requested URI to some kind of command to be sent to the parser and repackager, and then process the MP4 file to generate the playlist or segment, and then return the result. First is how we are going to create segment files. A video is just a sequence of frames. Each frame is either iframe or pframe. Iframe contains all information required to decode itself. Pframe doesn't include the full information, but it only contains the difference between the current frame and the previous frame. In order to decode pframe, you need the current frame and also the previous frame as well. If we know the segment boundary, then we only need to run FFmpeg with these parameters. If you set 0 as the starting time, 10 as the ending time, then you get the 10-second segment. You can generate the next 10-second segment and another 10-second segment. It looks pretty simple. However, in a real-world example, this is not going to happen. In a real-world example, if you do a segment like that, then you get these kind of segments. It is not going to work because segment doesn't start with iframe, then the player cannot play the segment. So how do we cut a segment from MP4 file? We have to cut a segment so that each segment starts with an iframe. That is challenging because keyframe location is unpredictable in 99% of MP4 files. And so segment duration and segment boundary is also unpredictable. So we need to know exactly where keyframes are located before we do anything, before we try to generate playlist or segment. How we can do that? We can extract the metadata from the MP4 file. The simplest way is to use ffprop. Ffprop is a tool that comes with FFmpeg. Instead of processing the MP4 file, it only extracts the metadata from the MP4. If you run ffprop with these parameters, then you get the location of each keyframe. Then, once you know the location of keyframe, then you use that information to generate the playlist file. This is what the HLS M3U8 playlist file should look like. We can create a template from the syntax of the M3U8, and you apply the segment boundaries extracted from the MP4. Then, if you combine that information, then you can get the concrete M3U8 file for that particular MP4 file. Then, In this example, we know these segment boundaries, and we use that information as the suffix of each individual segment files. Then the player makes a request for the segment using this file name with this suffix. Then the server can know exactly what segment the client is requesting. So for example, if the client requests this file, that means the segment starting from 17 seconds from the beginning. Then the server can use that suffix as the starting time. Then we can cut the segment that starts with iframe. Then the first FFmpeg is to cut the segment, and the second FFmpeg command is to repackage the generated segment into MPEG-2 TS format. Dash segments and manifest, the playlist, can also be generated using the same way. We have the template for MPEG-MPD, and we know the segment boundaries using the same method. Then we can generate the concrete MPD playlist for MPEG- using those two information. Then the dash player receives the particular playlist file and starts requesting the segments. Something that is different in MPEG- is because segments are in fragmented MP4 format, and that requires the video and audio separate in separate segments. So first thing is not just cut the segment into the smaller chunk, but we also need to split the video from audio, and then package the video segment and audio segment separately. So once we have the repackaging and parsing, then we can simply set up a rule in NGINX config. So when we receive a request for playlist or segment, then the FCGI only need to call the FFmpeg and FFprop to process the MP4 file to generate the HLS or MPEG- files. Supporting HLS 7 and up is a little challenging because it is not offered by anything. NGINX RTMP module and NGINX Plus both create HLS files based on HLS version 3. That is pretty old version. What is special about HLS version 7? That was announced by Apple a couple of years ago. The biggest difference in version 7 revision 20 is that HLS now supports fragmented MP4 format for its segment. That is a huge benefit because MPEG- and Microsoft Smooth Streaming are using fragmented MP4, and older version of HLS only supported MPEG-2 TS. So if we wanted to support both HLS and MPEG-, that is going to cover over 90% of the client base. We have to prepare segments in two different formats, MPEG-2 TS for HLS and fragmented MP4 for MPEG-. But from version 7 revision 20, HLS starts supporting fragmented MP4. So now we only need to generate one type of segment file, and that can be reused for both HLS and MPEG-. So because we only need to generate one type of segment and reuse it for both protocol, we can save storage for caching, and also we can save the CPU and memory resource to generate those segment files. And also another benefit is because fragmented MP4 supports separate video and audio segments, if you want to support multiple language in older version of HLS, like HLS version 3, the only way you can do to support multiple audio channel is to prepare separate segment files. Each segment has both video and audio. The video portion is duplicated across all segments for different audio. And that is not very good because video data is typically much larger than audio. So in order to have multiple variation of this portion of the data, you have to duplicate this much of data in each different segment. But with fragmented MP4, because video and audio are in separate segments, you only need to generate different audio segments, and you can reuse the same video segments for different audio tracks. Another minor change in version 7 is HLS 7 now requires master playlist. What is master playlist? Master playlist is a playlist of playlists. The regular media playlist has a list of segments. Master playlist has a list of other playlists. In older version of HLS, it was only necessary if you want to support multi-bit rates. Master playlist has separate playlists, and each one is for different bit rate, and the client player makes a decision which bit rate it wants to play, depending on the network condition and the device resolution. But in newer version of HLS, even if it is single bit rate, master playlist is still necessary. This is what the playlist look like. The left-hand side is the older version of HLS 3 playlist. It has a header and it has the list of segments. On the right-hand side is the HLS 7 playlist. The upper side one is the master playlist. It has another playlist. This is media playlist. Because it is single bit rate, it has just one M3 weight. And if you go to the media playlist, then you get this one. It looks almost the same with the older version of HLS playlist. But here you have .mp4 as the segment file extension. In older version of HLS, it had .ts as the segment file extension. The newer version of HLS now supports fragmented MP4. In HLS 3 segments, both video and audio are embedded in the same segment. And in new HLS 7, video and audio are separate. And in old HLS 3, the segment is packaged in MPEG-2 TS format. And in new HLS 7, they are packaged in fragmented MP4 format. How we can generate those HLS 7 playlist files and segment files if we use NGINX RTMP module. NGINX RTMP generates HLS 3 files and MPEG- files, but it doesn't support HLS 7. But there is a simple trick to convert HLS 7 and MPEG- contents into HLS 3 and MPEG- contents into HLS 7 contents. HLS 7 needs these two playlists, the master playlist and media playlist. They look very different from the MPEG-MPD playlist file, but if you take a closer look at the file, it has those informations like bandwidth, codec information, resolution, and the list of segments. They are all available from MPEG-MPD playlist. Even though the file syntax look very different, they contain the same kind of information. So if you just set up a FCGI script, so if you receive a request for HLS playlist file, then the FCGI script, instead of returning the HLS playlist, it tries to read the MPEG-MPD playlist and process it with simple regex string replacement. Then you can convert MPD file into HLS 7 playlist. Then everything can be done by a simple rule, simple regex rule, and the MPD playlist. Then what do we do about the segments? We don't need to do anything because fragmented MP4 segments are already generated by NGINX RTMP module for MPEG dash. We can just simply reuse those segments without any modification on it. Many people want to encrypt their file for security. If it is not encrypted, just a regular unencrypted HLS, the client makes a request for playlist and then request for segments and just starts playing. If it is encrypted, then it requests one more, the key file, and uses the key file to decrypt segment file. NGINX RTMP module supports encrypted HLS based on HLS 3, but we are offering HLS 7, and in HLS 7, the segments are not from the HLS directory, but from the MPEG dash directory. So we need to process it once again to encrypt it. This is how it can be done. So if you want to encrypt the file, then maybe by using a FCGI script or something else, you only need to insert this additional line in the playlist file with encryption method, the key location, initialization vector. The most common way of encryption in HLS is AES 128. Then the key file has to be a 16-byte binary. And in most use case, initialization vector set to 0 is good enough. Then, if you serve segment, then you can also set up a FCGI script that doesn't just read the file and return it. It reads the file and run this OpenSSL with these parameters to encrypt it. Then just return the result of this. High bitrate is becoming more and more common these days. What is special about high bitrate, such as 4K and 8K? Actually, there is nothing special. The only difference is it is a huge amount of data. Why it is that huge is because if you double the horizontal resolution and double the vertical resolution, then the number of pixels is not just doubled, it is quadrupled. So if you increase the resolution, then the size of data is exponentially increased. As a simple example, this is a recommendation by Vimeo. The primary purpose of this recommendation is to make sure that the uploaded file has to be in certain quality. So most stream that is offered by content provider has slightly less bitrate than this recommendation, but this is a very good guideline to understand how big 4K or 8K contents are. Compared to the standard definition, 4K is like 20 to 30 times bigger. 8K is even bigger. So if you try to stream 4K or 8K contents using the streaming infrastructure that has been optimized for lower bitrate, then it doesn't work. The typical symptom of too large resolution through the infrastructure optimized for lower resolution is typically you experience very large initial startup latency. If you start playing a video, then the video doesn't start for 7 to 8 seconds. Then eventually it starts, and once it starts, it constantly rebuffers. That is going to be very annoying. So most end users don't wait 7 to 8 seconds when they try to start the video. They just leave. So how do we handle the high bitrate case? Actually, there is no magic trick to make it work better. It just needs continuous optimization and customization to work it better. The first thing that we need to do is to make the segment duration smaller. The reason is, the bigger the segment is, it takes more time to prepare it and deliver it. So If the segment duration is 10 seconds, it means that in 50 Mbps bitrate, it will take a huge amount of time to prepare the file and deliver the file. If the segment duration is smaller, then it becomes much quicker. So the end user may not see that large initial startup delay. So the stream can start much quickly. In order to do smaller segment duration, you also need to reduce the keyframe interval. And if you want to offer 4K or 8K video, you have to prepare the contents in multi-bitrate because there are still a lot of client devices that are not capable of playing 4K or 8K stream. Sometimes because of the network limitation, sometimes because of the limitation on the device resolution. So if you don't want to lose those client devices, you have to prepare the content in multiple bitrate. And also network optimization is necessary because we don't want to have every large segment have to travel all the way half the globe. We have to make sure that the edge cache server and the original content location have to be set to somewhere close to the majority of the clients are coming from. H.265 is an option, but today in 2018, that is a little tricky. Not every open source players support H.265. So if you have full control of the player, so if you build your own player, then you can consider H.265. But if you rely on a third-party open source player, then probably you will have to wait a couple of years before H.265 becomes a common feature in most open source players. Low latency is probably the biggest topic in today's streaming industry. Actually, it is one of the typical examples that newer technology has something inferior compared to the legacy old streaming technology. In legacy old streaming technologies, such as RTMP, the end-to-end latency was not that huge. The reason was because the encoder just pushed the data as soon as the frames are ready, and each frame is delivered through the persistent connection from the encoder to the edge cache network, and then finally to the end user without having to wait somewhere in the middle. So the end-to-end latency of 3 to 4 seconds was pretty common at that time. But now, since the whole streaming technology has shifted to HTTP-based method, the whole situation is very different. Everything, the playlist file and segments file have to go through this step by step, and encoders generate the segment of certain duration. If the segment duration is 4 seconds, it means that the segment is going to be available only when the last frame is going to be available. So the first frame is, even though it is available from the encoder doesn't complete the file until the last frame is ready. So in case of 4-second segment, 4 seconds of latency is already inserted at the beginning from the encoder side. Then it adds extra latency when the file is pushed to the network, and then another extra latency when it is delivered to the end user. And finally, in the client device, the player tries to keep buffer that is as large as possible. That is the biggest portion of the whole latency. The reason that the client player tries to keep a large buffer is because the primary concern of a player is to play the stream seamlessly without interruption. It doesn't care about the latency. So the player doesn't know what kind of network condition it is going to have after 5 seconds. So it just keeps trying to have sufficient buffer in order to make up, even though it experiences some temporary network issue or whatever kind of glitch. So the most common end-to-end latency that we can see today in streaming industry is around 45 to 60 seconds. In some use case, it's acceptable. In some other use case, it is not. So we also need to do a lot of continuous optimization to make the latency shorter. The most important thing is make the segment duration small, because if the segment duration is large, such as 10 seconds, then the whole segment is only available when the full entire 10 seconds of video is added to the segment. So smaller segment helps. And in order to have smaller segment duration, we also need to have smaller keyframe interval. And then the player side buffer can be minimized, but we don't have full control over the client side buffer. The client just tries to keep as large buffer as possible. So in order to enforce the client to start the video without filling a very large buffer, all we can do is to minimize the playlist window. Instead of having 5 or 10 segments in a playlist, we include only 3 segments in the playlist. Then the client does not have any option, but just start playing with only 3 segments in its buffer. We also need to have network optimization to minimize the travel time of each segment from the encoder to the end user. And one of the biggest improvement can be made using chunk transfer encoding. Chunk transfer encoding allows us to start sending the segment even before the segment is complete. So the encoder is still appending at the end of the segment, but the first part of the segment can be sent to the network right away, even without knowing the exact size of the segment. By this way, we can minimize the latency that is caused by the encoder. That is all that I wanted to cover today. Thank you very much.